In this video, we'll talk about the vertical asymptotes and the corresponding multiplicities of rational functions. Here we have three rational functions, and for each rational function, we want to find the domain, if it is in lowest terms, if there are any holes in the graph, and the vertical asymptotes and the corresponding multiplicities. Okay, let's start from the first function. Let's start from the first function, r of x equals x over x plus 2. Let's look at its domain. I know for the domain, we shouldn't let the denominator here equal to 0, right? So the domain should be all the x such that x is not equal to -2, because -2 will make the denominator here equal to 0. Or you can say it's from -infinity to -2 union -2 to infinity. That's the interval notation. Second question, is this function r in lowest terms? That means we need to check if for the numerator and the denominator we can find any common factors. Well, they're pretty much factored out and there are no common factors to cancel out. So yes, this function is in lowest terms. Since we cannot cancel out any common factors, there are no holes in the graph. So here I say no. Okay, question number 4. What are the vertical asymptotes and what are the corresponding multiplicities? So for vertical asymptote, we look at the denominator in lowest terms, right? So the denominator is x plus 2, so the corresponding real zeros is the vertical asymptote, which is x equals -2, which is a vertical line. And the multiplicity here is 1, since this factor x plus 2 only appeared once in the denominator, right? So since the multiplicity is odd here, that means when you graph this function r of x, so here is the vertical asymptote, x equals -2, that means the graph on the two sides of this vertical asymptote x equals -2 will go to two different directions. One will go up, one will go down. Right now we don't know which side will go up, which side will go down. So I will say two cases. So first case is on the left side, the graph will go down. On the right side, it will go up. And the other case is, again, this is the vertical asymptote x equals -2, and on the left side is going to infinity, and on the right side is going to -infinity as x getting closer and closer to -2. Okay, now let's look at problem B. Okay, first I want to look at the domain. For the domain, you want to exclude whatever number that's making the denominator equal to 0, right? So we will set the denominator here equal to 0 and solve this equation. Excuse me, it's plus 2. X plus 2 times x plus 1 equal to 0. So you have two solutions. One is -2, one is -1. That means we need to exclude those two numbers from the domain. So your domain is all the x such that x cannot be equal to -2 or -1. If you want to represent it in the interval notation, you will write from -infinity to -2. let's draw a number line. So it's all real numbers, but these two. Right, so far we have this part, then the middle part, this part. So union, that's from -2 to -1. And then last, this part, that's union from -1 to infinity. So domain in interval notation is this. Okay, second part is this function in lowest terms. We just factor the denominator, right? So the top is x plus 1. The denominator is x plus 2 times x plus 1. And it's not in lowest terms because they have x plus 1 in common, right? So second, we say it's not in lowest terms. So not, but can we cancel out x plus 1 from the numerator and the denominator? The answer is no. The function f here is not the same as 1 over x plus 2, which is after you cancel out x plus 1, because they have different domains. For this function, y equals 1 over x plus 2. The domain is all real numbers but -2. But for function f, the domain is all real numbers but -2 and -1. Right? So they have different domains. So let's look at number 3. Does this function has any holes in the graph? The answer is yes. There is a hole. Where is the hole is wherever the common factor of the numerator and the denominator is. So it happens at x equals -1. There is a hole. At x equals -1. So our graph is very close to y equals 1 over x plus 2. Well, we can actually graph this one. Is moving 1 over x 2 units to the left, right? So it's kind of like this. This is our graph. This is -2, -1. So where is the hole in the graph? It's right here at -1. So this is the function f of x. So notice the graph of f is not exactly the same with y equals 1 over x plus 2. The only difference is there is a hole there at x equals -1. Question number 4, what is the vertical asymptote and its multiplicity? We kind of answered the question earlier. So the vertical asymptote is the denominator after you cancel out the common factor. So the only term left, or the only factor left is x plus 2. So x equals -2 is the only vertical asymptote here. And x plus 1, that factor is being canceled out. So x equals -1 is not a vertical asymptote. And the multiplicity of this vertical asymptote, x equals -2, is 1 because that factor, x plus 2, only appeared in the denominator once. You can actually see it from the graph, right? On the two sides of this vertical asymptote, x equals -2, you can see the graph is going to 2 different directions. That is because the multiplicity of this vertical asymptote is odd. Let's look at the third function. Okay, first of all, the domain here, we will look at the denominator, right? The zeros of the denominator is 0 and -2. So we can say the domain is all real numbers but 0 and -2. Of course, you can write this in the interval notation. It's the whole number line except -2 and 0. So it will be -infinity to -2 union -2 to 0 union 0 to infinity. Okay, that is the domain. So to answer the second question, is this function h of x in lowest terms? Looks like it is, right? So it is in lowest terms. To answer the third question, since it was in lowest terms and we couldn't cancel out any common factors, there are no holes in the graph. Okay, now number 4, what is the vertical asymptote and the corresponding multiplicity? Well, since it's the lowest terms, all the real zeros will be the vertical asymptote. So we have 2 vertical asymptote. One is x equal to 0, that vertical line, and the other one is x equals to -2. Right, the multiplicity for x equal to 0 is 1 because the corresponding factor x only appeared in the denominator once. The exponent is 1. Right, the multiplicity for x equals -2 is 2 because the corresponding factor x plus 2 appeared twice in the denominator. That means the exponent for that factor is 2. Okay, so how does that affect our graph? That means on the two sides of the vertical asymptote x equals 0, on one side it will go down. Let's say one side it will go this way. Then the other side of x equals 0 must be going up, all the way up. And for x equals -2, this vertical asymptote, since the multiplicity is even here, then if one side is going down, let's say here is going down, on the other side needs to go down also. So the two sides of the vertical asymptote is going to the same direction, either both going down or both going up. Okay, this is just a rough graph. We don't know more information, so we don't know how this part looks like, but we do know the multiplicity of the vertical asymptote. Therefore, we know how the graph behaves on both sides of the vertical asymptotes. This is the end of the video, and I will see you in the next video.